In a survey of 1,100 people, 835 people said they voted in a recent presidential election. Voting records show that 73% of eligible voters actually did vote. Given that 73% of eligible voters actually did vote, in part A, we want to find the probability that among the 1,100 randomly selected voters, at least 835 actually did vote. So the first thing we want to do is identify the values of n, p, and q. We know that the sample size n is equal to 1,100. The probability is 73% is 0.73. And the complement of that, which is q, which is 1 minus 0.73, is 0.27. So now what we're going to do is we're going to calculate the values of n times p and n times q. And we want to check to make sure that they're greater than or equal to 5. So we know that n is 1,100 times p, which is 0.73, which gives us 803, and that is greater than 5. 1,100 times q, which is 0.27, gives us 297, and that is also greater than 5. Therefore, we can say that the normal distribution can be used to approximate this discrete probability because of the fact that those are both greater than or equal to 5. In step 3, now we want to be able to find the mean and the standard deviation. The mean is equal to n times p, and the standard deviation is the square root of n times p times q. We've already found the mean up here, but n times p is 1,100 times 0.73, which gives us 803. Standard deviation is equal to the square root of 1,100 times 0.73 times 0.27, which would be the square root of 216.81. Rounding it to 6 decimal places gives us 14.724469. Now in step 4, we want to be able to draw a normal distribution that's centered about the mean of 803, and then draw a vertical strip area centered over x equals 835. Since it is at least 835, it does include 835 and above, so we shade to the right of the continuity correction. So let's draw the bell curve. And then make sure that we label our mean. So we know the mean is 803. And the value that we want to draw here is 835, which is to the right of that value. Okay, now recall that we're looking for at least 835. So at least means that we have to include the 835, and it's going to be to the right of the continuity correction. So a continuity correction represents a discrete whole number x by the interval of x minus 0.5 to x plus 0.5. So since we need to include 835, we need to subtract 0.5 from 835 to get 834.5. So over here, we're going to represent that value to be 834.5. And then what we want to do is we want to, since again it's at least 835 and it's going to include 835, let me make sure that that number says 835 there, so this should be 835. And so we want to shade to the right of 834.5. Okay, now that we've done that, now we need to convert that 834.5 to a z-score. So we're going to draw the z-scale right underneath our bell curve. Therefore, the mean is going to be 0. We want to find out what is the z-score for 834.5. So to find the z-score that corresponds to 834.5 and then rounding it to 2 decimal places, we're going to use the mean to be 803 and the standard deviation of 14.724469. Let's plug it into our z-score formula. 834.5 minus 803 divided by 14.724469 gives us 2.139296. Rounding it to 2 decimal places gives us a z-score of 2.14. So therefore, our z-score up here is going to be 2.14. We want to find the area that's to the right of that z-score. So let's go ahead and open up StatCrunch. We're going to go to Stat, and then Calculators, and then scroll down to Normal. And so what we want to do is we want to then make sure that the mean is 0, the standard deviation is 1. We want to make sure that this is changed to greater than or equal to, because we want the area to the right side. And then we're going to plug in the z-score of 2.14, and that gives us our area that we're looking for, or the probability. Okay, so now that we found that probability, now we want to be able to round it to 4 decimal places, which gives us 0.0162. So the area to the right of z is equal to 2.4 is 0.0162 rounded to 4 decimal places. Therefore, the probability that at least 835 actually did vote is 0.0162. Now in Part B it says, what do the results from Part A suggest? We want to interpret the probability. Since the probability of x is greater than or equal to 835 is less than 5%, it is highly unlikely that at least 835 of 1,100 people actually voted. Probability is 0.0162 is less than 0.05. So you would say that some people are being less than honest because the probability of x being greater than or equal to 835 is less than 5%.